Hello, ladies and gentlemen. My name is László Delay. I welcome all of you at today's DEX session. So one of our first session and presentation will be about the science behind the AI. And let me introduce our great presenter, Mr. Johannes Bernhardt. He's CEO of Bonn Consulting, whose extensive experience in guiding enterprise to AI implementation and gives him a front row seat to the cutting edge AI science and what is behind. So the floor is yours. Please go on with your presentation, and after that we will conclude it. Thanks.
Thank you so much. I really think I don't need that. You need it for the, okay. Sorry. Johannes Bernhardt, I was introduced. Thank you very much. What we are going to talk about today is a few simple things. What is behind AI? Because we saw the nice lecture given by the CEO of the bank, where different models of AI are introduced, and I would like to dive a little bit into that and see what's under the bonnet. So, what is it really? The thing that is confusing to a lot of people is that AI is much more than what we can see at the very moment. The big LLMs that are out there, the big things that are in the advertisings, and of course the fake news that are being created, that's the things that you can see. What really happens is that your smartphones are using it in extensive and vast ways. And companies producing them are making a lot of effort in order to try to create better user experience and to provide new functionality, relying heavily on complex algorithms and heuristics, and of course trying to understand the pattern recognition behind your user interactions. So ChatGPT and the large language models, I'm not going to phase on, because that's right over the news with everyone. I think that should be self-explaining. But the dive into the technologies being used, that's the thing that we're going to talk about. And we go in with a question, what is it really? So we have AI, which allows a machine to recreate or create patterns that it has learned from a human behavior. We have machine learning that bases experience-based learning into new actions, but on a limited scale. And you have deep learnings, which allow a machine to identify a task that is before it and to use large and complex data in order to understand what it is doing. That's a lot of where the fun is. So in the field of AI, you have certain types of it. You have the weak and the strong or general AI or generative AI. The funny thing is that a lot of people are focusing on the generative parts of it, whereas in the industry, people are leaning towards shallow learnings in order to solve tasks that are right at hand. One of the examples is that German government, together with a United Nations initiative, has tried for how do we understand agriculture and digitalization, because every farmer who uses large products like John Deere, Claas, and whatsoever has GPS in order to do his drilling. So nice, lean drillings. The neighbors are not complaining anymore. This is all sweet. But is there an effect that we can predict harvesting, that we can predict humidity, that fungus, insects, and whatnot are based upon in order to make the farmer's life easier. And this is where deep learning is not helping you. You need to be able to define a task, to define an outcome, and to allow the machine to interact within these patterns. So this is why the so-called weak AI is so important for a number of use cases, whereas the big publicity, of course, is in the strong AI cases where the big money is, where the big energy consumption is, but still where the question is open, what is the outcome? What will be the benefits for a society in the larger case? And when you look at the number of initiatives like the French based AI model or the Germans with Aleph Alpha, who are trying to understand the effects that an AI can have in science, in helping to explore things that we haven't seen before, to understand patterns better than a human could do that. So that's what we're talking about. And then, of course, I will very slowly read every single sentence on that. Why is it so important? Because we're trying to understand where it all comes from. Basically, everything on that page is about pattern recognition. That is where it all comes from. And I'm sure that most of you have been reading the papers that were brought out in the 80s, in the early 80s of last century, where people were dreaming about the mathematical models of what AI can do, and they were all true. The big misfortune they had was they were living in a time where processor capacity, where computer capacity was not there to give proof to their theories. And unfortunately, a lot of them didn't live long enough to see it coming. But it came exactly that way. So they were right on the one hand side. And secondly, it must not be forgotten that all that rah-rah on the advertising world, it's all about pattern. With 99.9%, everything that achieves a goal in the artificial world is based on that mechanism. So when you try to converse that understanding into deep learning efforts, you will see that it is quite similar to it. So the basic thinking is still on the pattern side. The only thing is that you create more layers in order to make a machine understand a very complex task. The overall philosophical principle behind that is still the same, and I find that still fascinating. So with all that work done there, we are, and that's the raw that is going out in the economy. We're talking about pre-trained deep learning models. And with that, we come also to the dangers of it, because what happens is, confusing to a lot of people, it's all about statistics. It's stochastic, it's heuristics. So if you take the time and effort to develop a mathematical understanding of what you're doing, your life becomes much easier. So, but I don't want to drive into the key concepts of it, because that's only for the connoisseurs. But I would rather go and talk to you about what are the types that we can use and that we're working with. Because out of all of that, how do we facilitate the learning aspects? The learning aspects are indeedly the supervised learning. That's how we started in the 90s even, with trying for risk management and analysis, where we tried to form very simple neuronal networks. That was all we could do because we didn't have the computing power. But to try to understand, when a risk pops up, a road is blocked, what is the effect on a whole supply chain? And we have been refining these concepts until today. So these applications have gone through numerous renovations, but they are still running on the same patterns, which is totally amazing. So that shows you that once you, and that is one important learning, which also the MIT has put as their standard for the survival capability of an AI-based application. When the incoming variables allow you for a certainty of about 80% of your prediction, it is very, very likely that you're good, that you will reach the target that you come from. If the quality goes down to 50%, there is a major risk. If it is below 50%, don't try for it. The probability that you fail is maximizing, not on a linear, but on a progressive curve. So that's when things become very, very difficult. So, and with that, we're with training, because now we have the possibilities to really go through patterns that allow us to tell the machine in which direction to go. And of course, collecting labeled data, training a model, using these data, and evaluate the model again and again with the learnings that we have. That's how we do the job. So still, unsupervised learning basically is the same. What's different is that the machine does it on its own. We even go that far that we ask a machine to form a task. We just put data in front of it and say, find something useful to do with it. Is a lot of fun, but the economic value of it might still be coming or not. But it's a lot of fun. Again, when you look at what can be done on the combination of supervised and unsupervised learning, where you go into the reinforcement patterns, that is where you all remember the chess or Go parades where Kasparov was losing against a machine. And exactly. And nowadays, no human can win a game of Go against a machine anymore, which is, especially for the Japanese amongst us, really a bummer. So, but that's what it is about the reinforcement learning. But what we learn here is how important the agent pattern is. So what's the purpose? What are you doing with it? And if you are trying to think it from an end, you might come to totally different outcomes, even in your journey throughout the interpretation of the data. Wow. Interpretation of the data, that was a little bit too much. Hold the gun. It's all about how are we able to get meaningful data and insights into a use case that we really want to achieve. And that's how we go through it. The model is simple. I won't dive deeper into it. It all follows the pattern that I've described already, but it lays the basis for neural networks. Why is that so important? Because the understanding of the statistical background and the quality of the data gives you an outlook on the perception, this is not working well, on the way a neural network works. So the intake of the data, the layers that really do the job behind that, and the output layers have to interact on the basis of the data that you give them. With that, we try in a number of use cases to understand the bias that a system necessarily evolves, but we don't understand why, which is absolutely funny. And I'm really keen to understand. One day we will understand it, and I'm really looking forward to know what's really behind that. One of the answers we strongly believe is in the field of the perceptrons. Perceptrons are copies of biological cellular processes which are copied into the binary world. So, and I remember the discussion that we had about quantum computing and DNA-based computing, which still is not over. So that will be fun as well. But the concept of how we're doing it is indeedly a copy of what we understand about the human brain. And this is about the input signal, the weights, the bias, and the activation functions that are there. This is neurobiology, funnily enough. This is not a mathematical concept. So that's why I'm so intrigued about it. So when you try to understand that functionality and the mathematical graph behind that, you will find, I'm so sorry, but this is, you will find that there really is use behind that, because you can put these neural networks and perceptrons into transforming networks and large language models. This was the whole mathematical basis about that. So if you're now trying to translate a how are you in a como estás, which is a quite simple task, from a mathematical perspective, it is not, funnily enough, because input, transformer, and output data are really, really complex. And this, of course, is not a really bad task to perform. But if you do that with your dissertation or a more complex task, you need a lot of energy and a lot of algorithms behind that in order to get the labels out. So, and with that, I just skipped that and asked you, I'm so sorry. With that, we come to a point that is very close to my heart, because we are working in a number of initiatives that are depending on the functionality of the neural network, of the AI. Why is that? Because we have been building a data space for the prediction of energy. So production, consumption, pricing, weather conditions, emergencies that allow a state, a country, or an industry to predict on will they have enough energy to produce. Funnily enough, one of the things that the Germans are really great with is to invent something that is cool and then leave it. So with the change from predictable energy sources into our industry only works when the sun shines and the wind blows, because we're doing it as green as we can, possibly is not the right way, but the government at the very moment is taking its own sweet time to understand that. So these models are used in other countries. They are used very well. But there, of course, you need a certain level of accuracy. You need things that help you to improve the quality of what you're doing. Test data. So the test sets, the train sets, the validation sets, that's where the music is, that's where the charms are in order to get a model across these magical 80% of entry data validation that allow you for a proper mathematical model. And then again, the thing that we understand the least and fear the most is bias. Systems develop bias. You all remember that Chicago Police Department thingy about prediction of crime areas. It totally went south because the system became racist. And funnily enough, it was looking at colored people's crimes, but was totally missing out on the organized Albanian gangs that did the same business on a much larger scale. It didn't see it. Why? Because it was biased. And I was part of an initiative at the MIT that tried to understand, why is that? Is it only the police reports by white male policemen, Radira, who are all right-winging, black-hating people? No. we were not able to understand in depth what's the problem with it. So a systematic error of a system must be combined with the understanding of the incoming data, yes, but how it really works, nobody knows. Honestly, we cannot answer that question. And I believe that with a number of what we've heard this morning already, this will be one of the bigger tasks that from a scientific as well as from an industry perspective, we need to learn. So you see the curves on the right, overfitting and underfitting are mathematical problems. It leads to results that you don't like, but thank God you understand why it is the way it is. Unlike bias, which really is complicated. Confusion matrices, you all know about, true falses, true positives. It's not as simple as it looks on that quadrant, but there are ways to get there. And even with what we had in the morning about generated deep fake videos or tonalities, there are ways to get there. Metadata recursion and other methods really can help you to get a grip on that. So if we go on, the validation metrics I've been talking about 3 times now. I spare you the in-depths of it. And we go on. Thank you. Questions? No questions? Any questions? Not even a little one?
If may, I just make a summarize note. So first of all, thank you very much for your presentation. It was very interesting and very up to date, providing insights what is behind really the AI. And I'm just thinking about 2 things. Nowadays, the AI is very crucial. So we can say that I don't want to I don't want to work with it as for example, as a financial executive or just one employee of a big company. So I'm just wondering whether it is very perfect presentation. I was wondering if it's possible to bring all this stuff a little bit closer to the everyday people, let's say, because we also learn that different methods, different architectures needs to different projects and so on, and we learn that if we get the best data, then it will result in the best efficient AI. This is one thing. And let me give another remark as well. So because since I'm a cybersecurity expert, I'm just wondering whether it is possible or to be, maybe we have a solution, I don't know, on the market. We should think about the self-defense capability of this AI model, because what I'm thinking about is that if bad actor tamper the training modules and training datas, then the result will be totally crashed and will not provide the efficient results, and the researchers will. So you mentioned just a very good example for that, the police department. So maybe that happened at that place as well. I don't know. So yeah, that's it. Thank you very much.
Thank you very much. These are 2 very important remarks. And let me come to your first remark first. When I was a young guy, I wanted to see the world. I joined a consulting firm and was traveling, and I had to work long nights doing a lot of PowerPoint, which I hated. And what I learned there is, if you have a message for the upper ranks, make it understandable for a 6-year-old. If you don't do that, you fail. Unfortunately, it has proven true. So if we understand the use cases of what I just have been trying to show you in agriculture, in energy, in the automotive industry, make it simple. Make it as simple that people can understand it. You can hope for a love for mathematical understanding in everyone, but this hope might be a sad story. So if you can't make it simple, better don't do it. And we are living through that. We're consulting a number of very large companies with managers who have a very short attention span. If you can't break it down to 3 simple sentences, you're done. So you really need to think what you're doing there. The second thing is, I believe, the most critical remark, because the first thing that can be solved somehow. The second thing is the critical part of it, because from a cybersecurity aspect, the use of large language models is a nightmare. You have no control on the bias. So what we do when we work in difficile industries, especially in the energy sector, we stay away from large language models and develop so-called specialist language models on our own, where we take the pain and responsibility to look through the input data in order to understand what the output is. Since what I said is we have no clue how bias really works. There are attempts for a mathematical explanation of it. Not entirely sure. And I stand here and have honestly to say, I don't know. So we have to put research behind it. We have to do a lot about it. What we're doing now is to isolate it to the core that we have designed it for, and to be very, very careful in order to what data do we allow into a system. And of course, on isolated trunks, we're experimenting with how the hell does it work and why does it react the way it reacts. But it's still experimentation state.
Thank you very much. Balázs, what are you thinking about all these things? And I'm mostly the second topic or questions raised. Thanks.
Thank you, Laszlo. So you were saying several times that we don't understand bias, and also imply that bias is bad. But there is a kind of bias in these models which we could call our culture. And so how do you approach that part, that aspect?
Thank you so much. That's a lovely question. Honestly said, I'm more on the problem side of that. The cultural identity, regional identity, or even idiom, if you look at text-based systems, are welcome biases. For me, it just adds, and I have to water that down. For me, looking at it from a mathematical and strategic perspective, it's just watering down my bloody model. So, can I find a way to distinct culture and regionality, or even craftsmanship? If you look at the slangs of IT people versus journalists, or. Yes, I can learn to understand that, I can learn the idiom, and I can respect that. What I find totally difficult to work with is the outcome of it. Because especially if you have to put that into large language models, you can't distinguish the one from the other. You can do that very easily. We tried that in a project called civic participation. So the German government does a lot to make people understand that there is a necessity to build railways and grid networks and. So the government wanted to understand, how does that sentiment work and why does it change? When a politician visits somewhere and the people go on the streets and throw things at him, which unfortunately happens more often than we would like to see that. But why is that? And how does it change over time? So we developed a tool where we try to exactly understand that. The major learning that we had is how to identify a bot or a malicious actor from a real person. But we could not identify good bias from bad bias. So if you use slang words, if you use dialect in speech, where are several models in the German language at least, I don't know how it is in Hungary, but that you can distinguish. but to separate the biases from each other, from my perspective, from the mathematical and technical perspective, is extremely hard.
Thank you very much. So we will have to stay tuned on that one.
Most
Another
definitely.
point that I was thinking as you were giving the example of Chicago Police Department and that bias is the story that my history teacher told us about Columbus discovering America, and that the indigenous population, they couldn't see the boats on the sea because their eyes were not trained to see that on the sea. It was something, a pattern that they've never seen. So that's, I guess, we are built the same way, to not be able to see the patterns that we don't know about.
The insecurities, unfortunately, one of the younger Bushs misused the phrase to beyond recognition. But the truth indeedly is, I'm mildly afraid of the things where I do know that I don't know them. What kills me for sure is when I don't know what I don't know. Because I don't know even in which direction to look. I don't know the enemy, I don't know the cure, I don't know what will work. This will kill us for sure. So, are we not seeing the ships? Or is it Cortes, the killer, with his horses and some rusty armor already on land and making our lives difficult? I don't know where we are really. What I do know is that if you intend to use these technologies without ethical background and without ethical guardrails, we might face a problem. And that problem might be bigger than we're able to estimate to the very day. So I'm not a fan of these doomsayers who believe that the world will end in tears, blah. I don't see that. But I very clearly see what you can do with malicious deeds and how far you can reach with that. So, as always in life, measure produces countermeasure. Like the Mossad says, mikrim vet guvot. You give hard, you take hard. So that's what's happening at the moment. The Russians are coming up with new ways of trying to infiltrate networks almost on a monthly basis. And we're trying to chase them to their homeland now, which we haven't been doing before. So we're trying to find different ways of attack and counterattack. And I believe this will be the same thing with the ships on the horizon. Maybe we'll be able to see them.
Thank you very much, and that's an amazing segue, because now I can take your place a little bit, confer for you, because you will have a presentation later today where we will talk about compliance and the implications of AI and ethics and other compliance items.
Yes, this is a very interesting part of using AI to be aware that we have regulations to be compliant with, and we have to make sure that every requirements are, at the end of the day, are met and implemented. So thank you again for your presentation. It was great and highly appreciated.
The pleasure was all mine.
Okay, we're taking a break, and we'll come back with the next presentation in about 15 minutes, roughly.